Alrighty people, probability and data management lesson 2. Yesterday we did silly stem and leaf plots. Today we are going to do the mean. Mean, it's spelt the same way as like when somebody's mean to you, but it means something completely different. Another word for mean is average. And to be truthful, if it were up to me, I would use average, not mean. If you want to impress somebody says, what'd you learn today in your online school? What we're actually learning for the next few days are measures of central tendency. Sounds complicated, but it's really not. It's really about looking at a set of data and figuring out what the middle of the road is. Like if we look at the lesson from yesterday about the kids jumping long jump. So if we all long jumped and then we took all the scores, we could figure out what the most common jump was. That would be the mode. We could figure out where the middle was. Because you're going to have some kids like our son Craig who are phenomenal jumpers and jump way longer than anyone else. And my husband who cannot run and jump at all. It's his like kryptonite in life. So he would be at the low end, Craig would be at the high end, and it's useful to know where the middle is so that you can say whether you were above the average or below the average, or above the mean or below the mean. When you get to high school, when you get your report card, it will always give you your mark and the class average, which is a good measure of how you're doing amongst your peers, right? If you've got an 82 and the class average is a 75, you're doing well. You're doing better than at least half the kids, right? If you're above the mean, you are above average, okay? If you're below the mean, sometimes we're all below the mean, but it means you got to pull up your socks and get going. Being below the mean is not where you want to be, unless it's something bad. If you did something bad, then you'd want to be below. If people were doing bad things and you did less than the mean, that would be a good thing. Okay, on to today's lesson. So, in the first question, I am only going to do the first one with you. It is super easy, okay? You've got a bunch of beads. They have told you have to pretend this is like kindergarten, okay? And there's beads all on sticks. And they want you to find the mean. The mean is where all the sticks have the same number of beads on them. So you're going to take this bead and move it here and give it to this one. And now this one's gone. And you're going to take this one and give it to this one. So now, oh, I screwed up. Sorry. You're going to take this one and give it to this one. So now this one's gone. So this one has 3. My drawings, as usual, are terrible. But this one has 3, 3, 3, 3, and 3 when we move the 2 over. So when you go and do, so that means that the mean is 3. If I find the middle point where I can make all the stacks equal, that's the mean. So they call it the bead method. So you're going to go on to do the to do B and C, and you're going to move beads from the really tall piles to the really short piles so that in the end they all come out exactly the same. However many beads makes them exactly the same, that's the mean. Okay? Pause the video, go and move your balls. Okay, now we're actually getting into finding the mean without using beads, because I can assure you, when you get to high school, the teacher does not have 30 beads on a rack with everybody's marks on them. It's a ridiculous way to do it, but just so you understand, so you get a visual in your mind, that's why they're showing you the bead method, okay? To find the mean, you take your data. So say we've got 4, 3, 4, and 1. Okay, that's our data set. To find the mean, you're going to add them all up. Okay, so 4 and 3 is 7, 7 and 4 is 11, 11 and 1 is 12. Then how many pieces of data do I have? 1, 2, 3, 4. I'm going to divide it by 4. 12 divide, how many 4s make 12? 4, 8, 12. So that means my mean is 3 for this data set, which means if you scored 3 on whatever it was we were collecting, you would be average. These guys are well above average. This one is below. We don't know if it was a good thing or a bad thing we were counting, so we don't know who's actually in the right, but in any case, the mean is 3. So for number 2, they give you a data set of 0, 3, 4, 6, and 7. First job, add them all up. 0 and 3 is 3, 4 is 7, 6 is 13, 7 is 20. 7 and 6 is 13, 17, 20, and nothing. So it adds up to 20. How many pieces of data do I have? 1, 2, 3, 4, 5. I divide by 5. That's like the rods that you put the beads on. How many rods do I have? 5. How many beads are going to be on each rod? How many times does 5 go into 20? 5, 10, 15, 20. 4 times. So the mean of this data set is 4. Okay? You're going to go do the exact same thing for B, C, and D. Add the numbers, count how many numbers there are, divide by that, then you've got your mean. Okay? Pause the video, go and do that. Okay, compare the data values in the sets above. Each one is 1 greater than the same value in the previous set. In your notebook, explain how the mean changes when you add 1 to each data value. So if we had this, right, and instead of this being a 0, this is a 1, right? Well, now we know that this becomes 21 divided by 5. Well, 21 divided by 5 is more than 20 divided by 5, right? So now it's 4.25. So every time you add something to your data set, your mean goes up. If you add a number that's less than the mean, so remember our mean was 4. So if we added, oh, I screwed up. Let's try this again. Okay, so we had 3, 4, 3, 7, 6, and 7. That was our set, right? 7, 13, 17, 20. Yes. Here's where I screwed up. I added a new data value, but I forgot that now I have to divide by 5 because there's 5 data values, not 4. So now I have 21 divided by 5, which is 4.25, right? When before, I had 20 divided by 4, right? I only had 4 pieces of data. Oh no, I did have 5 pieces of data. All right, let's try this again. I've screwed up. All right, so 0, 3, 4, 6, 7. It added up 7, 13, 17, 20. It added up to 20. I divided it by 5 because I had 5. I know where I screwed up. I didn't add a data value, I changed it. It went up by 1. Okay, so we figured out that the mean was 4. What you need to know is that if I add a number to this, don't change it, add a number, right? Add a 1. If the new number I add is less than the average, it will drag the average down. If the new number I add is more than the average, it will lift the average up, okay? So you are gonna, that's the answer to the second piece. Okay, find the mean. So all you're gonna do is add the numbers and divide by how many numbers there are, right? So 0, 1, 2, 3, 4, 5. 5 and 4 is 9, 3 is 12, 2 is 14, 1 is 15, 0 is still 15. So I added them all up and I get 15. How many numbers? 1, 2, 3, 4, 5, 6. Okay, so we have, you may need to use a calculator because these numbers aren't going to come out as whole numbers, okay? So how many times does 6 go into 15? Well, it goes in 2 with 3 left over, and 3 is half of 6. So it's 2.5. So the mean is 2.5, okay? You will likely need a calculator for B and C to add the numbers and do the dividing, okay? The second part says, explain why the beads model does not help to find the mean in A. Well, how do you draw half a bead is the problem. That's what I would say why the beads model doesn't work. The beads model works when the mean is a whole number. When you have a decimal, how do you draw a decimal 3/7 of a bead, right? So that's why it doesn't work. Okay, so go do number 3, come back for number 4. Find the mean and draw a horizontal line to show it. So they've got 3 rods. First one's got 1, second one's got 6. My rod wasn't long enough. And the next one's got 5. Right? So they want you to find the mean. 1, 6, and 5. Add them up. 1 and 6 is 7, 5 is 12. 1, 2, 3 pieces of data, so I divided amongst the 3 rods, means that the mean should be 4. 1, 2, 3, 4. So I draw a line at 4. Okay? And then 1, 2, 3 extra beads would go down here so that you could see that it was 4 all the way across. Okay? 4 is very easy. Just add them up, divide by how many, and draw the line at that number. Okay. How does adding new data affect the mean? A data set 1, 4, 10. 4 and 1 is 5, 10 is 15. There's 3 data pieces, so my mean is 5, okay? Add the following data values to the set and decide if the mean went up, went down, or stayed the same. So they would like you to add a new data value of 3. So instead of having 1, 4, and 10, we'd have 1, 4, 10, and 3, which would be 5, 15, 18. 1, 2, 3, 4, divided by 4. I know 4 goes into 18 4 times with 2 left over, so that would be 4.5. So our mean on this data set was 5. Our mean on the new data set is 4.5. So is 4.5 more or less than 5? Right? So adding this 3 decreased the mean. Okay? And then they want you to add 4, add 5, add 6, add 7, add 8. So you're going to do the exact same thing, right? So say, let's skip to number 7. Now we'll have 1, 4, 10, and 7, which is 5, 15, 22 divided by 4. 22 divided by 4, 4 goes into 22 5 times with 2 left over, so that's 5.5. Now the mean went up because we had originally started with 5. Now it's 5.5. So by adding 7, it picked our mean up. We're increasing our mean because we have higher value data pieces. Okay? So go do the rest of those. Add them. Remember, you're starting with 15, and then you could just add 4, add 5, add 6, add 7, add 8, and do the dividing. Okay? Pause the video. Go do that question. Okay, second part of that is make a conjecture. A conjecture is like something you believe to be true. So when the new data value, a new data value is smaller than the mean you already have, what happens? So we're doing our long jump, and everybody jumps, and then Steve jumps, and he sucks. He doesn't go anywhere near as far as everyone else. So we have to add his score in, right? So say, our average was 80 centimeters. I don't know. 80 centimeters. He only jumped 60. What's going to happen to the average? He's going to drag it down, right? Because if we're thinking about the bead model, he has way less beads. So we have to take them from the ones on the top, and that keeps lowering the bar. Conversely, what if Craig jumps? And Craig jumps 110 centimeters. Now we've got way more beads sticking out the top to give to the lower ones. So it's going to raise the bar. So if you add a new data value that's higher than the mean, you're going to lift it. If you're going to add a data value that's lower than the mean, you're going to drop it. Okay? Test your conjecture with a different set of data. 2, 3, 7. First, find the mean. Easy breezy. 7 and 3 is 10, and 2 is 12. And I have 1, 2, 3 pieces of data. 12 divided by 3 is 4. So the mean is 4. Then add new data values above and below and find the new mean. So basically what they want you to do is test out our theory. So let's add a data value that is lower than 4. Let's go with 0. 0, 2, 3, 7. Still, 7 and 3 is 10 and 2 is 12. 0 is nothing. But now we have 4 pieces of data, so we have to divide by 4. 12 divided by 4 is 3. We added a low value data, and what happened to our mean? It went down. Okay? If you add a value that is the same as the mean, would the mean change? What do you think? Let's try. 2, 3, and 7 was our original set of data, right? 7, 10, 12 divided by 3 gives us a mean of 4. So we're going to add 4 to this data set. 4, 2, 3, 7. So this was 12. 4 would make it 16. 1, 2, 3, 4 pieces of data. 16 divided by 4 is 4. So if you add a piece of data that equals the mean does not change. It makes total sense to me. Okay, number 5. The data set, 3, 4, 7, 8, 8. Okay? Find the mean. 3 and 4 is 7, 7 and 7 is 14, and 8 is 22, and 8 is 30. So 30, and we have 1, 2, 3, 4, 5 pieces of data. 30 divided by 5, 5, 10, 15, 20, 25, 30. Goes in 6 times. Is the data 7? So our mean is 6. Is the data 7 above or below the mean? Well, clearly 7's more than 6, so it's above. Will removing 7 from the data increase or decrease the mean? Okay, so we've already decided that if you have pieces of data that are above the mean, they pull the mean up. If they're below the mean, they drop the mean down. So if I take out this 7, which is clearly more than 6, what's going to happen? It's going to drop, right? Because I took out something that was pulling it up. But let's try it just to be sure. 8 and 8 is 16, 23. So 23, and that's 1, 2, 3, 4 pieces of data, right? Well, 4 goes into 25 times with 3 left over, and 3/4 is 0.75. So it dropped our mean to 5.75 from 6. Okay? All right. I liked this question, actually. 6. 10 people. I can't. 10 people work in an office. Remember, 10 people. It's important. A salesman makes $50,000 a year. That's the salesman. Oh, we have to make it sales. The secretaries make $35,000. That's the secretaries, right? A clerk makes $25,000. Okay? There are 5 of these. There are 2 of these. And there are 3 of these. Okay? Find the mean salary in the office. So that means we have to figure out how much all 10 people make all added together and then find the mean, right? So if there are 5 that make $50,000, that means all together those 5 people make $250,000. If there are 2 that make $35,000, that means that they make $70,000 together, right? And if there are 3 that make 25,000, that means those 3 together make 75,000. Okay? So now I need to add this all up. 250 and 75 is 325, and plus 70 would be 395. So 395,000, right? That's how much the salary is for the whole office. Now, we have 10 pieces of data. 5 of those, 2 of those, 3 of those. 5, 6, 7, 8, 9, 10. 10 pieces of data. So I need to divide by 10. I know how to divide by 10. I see 1 0, so I skip the decimal place 1, right? So that means that the average salary, the mean, is 3,950, $39,500. That's the average, okay? So we did that. We found the mean salary. What is the mode? Think back to yesterday. Mode is the most common piece of data. So what were there the most of? Well, there's 5 of those and there's only 2 and 3. So the mode is 50,000. That's the mode, most common piece of data. It occurred 5 times. Everything else only occurred 2 and 3 times. What is the mean salary increase or decrease if a secretary retires? So we're going to get rid of one of the secretaries. She's going to go home and knit or something. I don't know. So now we're going to lose 35,000 off of our original total. But think about this, without even doing the math. A secretary's salary, is it more or less than the mean we had figured out? The mean was 39,500. A secretary makes 35,000. So by having those 2 secretaries in there, they were dragging the mean down. So by throwing away one of the low-valued pieces of data, our mean should go up because we're losing something that's pulling it down. So it's going to want to come back up. So if we're going to lose 35,000 from 395, that leaves us with a new total of 360,000. And, right, 395 minus 35, yeah, so 360,000. But now we have one less piece of data. So now we have to divide that by 9. Well, I know 9 goes into 36 4 times. So it's going to be 40,000. So our new mean is 40,000. And it was 39,500. So it came up. And it came up by $500. 39,500 to 40,000. It's a difference of $500. 39,500. Yeah, $500. Right? So it came up $500. Apparently my answer is wrong on the answer sheet. Don't know what I was thinking, but okay. We all make mistakes. Now, D, will the mean salary, so let's go back to our original mean salary, which was 39,500. Okay, that's our original mean salary. Will it go up or go down if 2 new salespeople are hired? So now we're going to add 2 more pieces of data at 50,000. 2 more 50,000s. What's going to happen to the average of 39,500? Is 50,000 more? If it's more, it's going to pull the average up. So it's going to pull your mean up. So if 2 new salesmen are hired, we are going to have an increase in the mean. Okay, go finish that question. We're on to the last page. Okay, count the spaces below the mean and the blocks above the mean. Honestly, I found this, as we get further into it, a little bit confusing, but we do what we do, right? Okay, so they're showing you a picture with 1, 8, and 6. So it has 1 block, I don't know how many, 8 blocks and 6 blocks. 1, 2, 3, 4, 5, 6. Okay? 6 blocks. And then they've put the mean at 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There. Okay? So they want, and then there's 4 blank spots here. Okay? They want you to count the spaces above and below the mean. Well, there are 1, 2, 3, 4 above. 1, 2, 3, 4 below. So I think you guys can handle that one without any further explanation. Count the blocks below and above. Okay, look at the answers to question 7. What do you notice? There are 4 below and 4 above. What do you notice? Well, the numbers above the mean and below the mean are equal. It's finding exactly the middle part that makes above and below equal. All right, go write that down. 9, the number of spaces below the mean is the same as the number of blocks above the mean. Write a number sentence to show this. Oh my Lord, so much drawing today. Okay, so I should have left it. I had it. Anyways, there were 4 equals 3 plus 1. So there were 4 here. Remember, there were 4 x's below the mean, and there were 3 boxes above the mean here and 1, because this was 8 and this was 6 and the mean was 5, remember? So you've got 4 below, it equals 3 plus 1, okay? So you're gonna do the same thing on the other ones, just look at the blocks above the mean and below, and the x's below the mean, and fill in the blanks. Easy breezy. Do the remaining parts on grid paper, draw the blocks, and find the mean first. I don't honestly care if you do that. I did not. What this whole lesson is concerned with is, can you take a bunch of numbers and find the average, or the mean, right? So 2, 6, 7. If you need to draw the blocks, you do you. Go for it. If you don't need to draw the blocks, I'm just as happy. So 2 and 6 is 8, and 7 is 15. Divide it by 1, 2, 3 pieces of data. The mean is 5. Okay? I'd be plenty happy if you just found the mean for those 3 pieces in that question, D, E, and F. Okay? Find data sets with mean for using the number sentences. Draw beads to help you. This was the part that I found confusing, I guess. So they've got 4 sticks, right? With 1 bead, 2 beads, 5 beads, 1, 2, 3, 4, 5, and 8 beads. 1, 2, 3, 4, 5, 6, 7, ooh, 8. That one's tipping over. So there are, and the mean is at 1, 2, 3, 4. 1, 2, 3, 4. So the mean is here, right? So they're showing you that there are 1, 2, 3 beads missing to get to the mean. There are 2 beads missing here, right? So they've got 3 are missing, 2 are missing, but I have an extra one here, and I have 4 extra ones there, right? So 3 plus 2 equals 1 plus 4. 3 and 2 is 5, 1 and 4 is 5, okay? So your data is 1 bead, 2 beads, 1, 2, 3, 4, 5 beads, and 8 beads. That's your data set, okay? Go do B and C. Okay, 11, create 3 different sets of data with mean of 6. Okay, if you can count by 6, this is very easy, okay? So we want, if it's a mean of 6, 6 has to divide evenly into it. So let's come up with some numbers that add to 6, or 12, or 18, or 24. And it doesn't tell you how many pieces of data have to be in it. So let's keep it simple, right? So let's say we've got a piece, something that's going to add to 6, and we'll only have 2 pieces of data, 2 and 4, right? 2 and 4 is 6, and then I divide 6 by 2, and I find out the mean is 3. I need a mean of 6. Pardon me. Pardon me. Oh my goodness. All right, so let's try this. 6, 5, and 7. 6 6 and 5 is 11, and 7 is 18. And I'm dividing it by 3, so I have a mean of 6, okay? So I had 3 numbers that, because 6 goes into 18 3 times, right? So let's do it with 24. We need something that equals 24, and in the end, and when we divide it by something, it has to equal 6. So the something is 4. So we need 4 numbers that make 24. Pick some, doesn't matter. How about 7 and 8 is 15, and then I've got 9 left, 3 and 6. Oh, that's not a 6. 3 and 6 is 9, 17, 24. Divided by 4 gives me a 6, right? So think about counting by 6s, and then how many 6s made that to tell you how many pieces of data you have to come up with to add to it, all right? Not sure I explained that well, but we'll figure it out. Okay, the mean of a set of data is 10. Data values are 2, 19, 7, 4, and 15. Plus something else, we'll call it x, okay? What is the other number? The mean is 10, okay? So all of this added up, so 2 plus 19 plus 7 plus 4 plus 15 plus x has to equal 1, 2, 3, 4, 5, 6. That's 6 pieces of data, and the mean is 10. So that means that it all has to add up to 60, because I'm going to divide it by, oh wait, 1, 2, 3, 4, 5, 6. Yeah, I'm going to divide it by 6, and that means the mean will be 10. So let's see what we got. 2 and 19 is 21, 7 is 28, 4 is 32, 10 is 42, 5 is 47. So we're at 47, and we need, so 47 plus x has to equal 60. What plus 47 equals 60? X equals 13. Okay? That's it. That's all for today. Have a good day.